Hi, Sportster Paul here, HSMWorks and fixtures. In a word, it's botched. And sorry, but watch this show and you'll see why. First off, to me, when you say CAM program fixturing, it helps you avoid those fixtures. It makes toolpaths, Visual Mill does this, Solid Cam, the best program does this. 2D toolpaths, no avoidance. You can do some goofy stuff. It's not super intuitive. And then, okay, it'll tell you had a collision, but it will not help you generate a toolpath that avoids those clamps. Okay, that's a problem. 3D, because they buy the Modular Works module to do all their 3D toolpaths, they've crowbarred in a avoidance, but boy, did I have trouble. It's not intuitive. You have to reestablish in the model section. You have to tell it, oh no, these are the clamps now. You have to do that over again. And then the biggest problem, to add the triple botch, the simulator. The simulator cannot simulate the entire, and there's only two operations I want to do. I want to face the top around clamps, move the clamps 90 degrees, finish the facing. There is no way to simulate that properly. Part of this problem is because they do not honor the stock conditions. So if you have 20 operations, you select way down in the tree and say simulate, it shows you the stock that you set up in the beginning, right? It doesn't inherit the stock from the previous operation. The 3D operations have this rest machining from previous job, previous operation, and that had some goofy implications that this might just be newbie, doesn't know the 3D toolpaths that well. But for 2D, what I've done is I've kludged up some sketches to do my own avoidance, and then we'll show you why the simulator doesn't work, because it's got the same problem in both situations. And then we'll do the 3D toolpaths. So, and I can't do this real time because it was so complicated. When I tried to do it from scratch today, I couldn't do it. So let's see if we can get going here. Let's go up to our favorite program, SolidWorks. We love it. Here's the same part I did in the Bobcat fixtures, Visual Mill fixtures, Solid Cam fixtures. Solid Cam is the capable program, right? Go watch that show. Here's 4 clamps. The intent, of course, there's going to be 2 clamps, and I'm going to move them 90 degrees. I call these pair the north-south clamps because it's going to sit in the vise like this, positive X off to the right. These are the east-west, EW clamps. And so if you go in the configurations, here's all the clamps. There's the north-south clamps. There's the east-west clamps. There's the no clamps. And I learned about configurations. Let's put them all back. So then in order to do a facing and have it avoid clamps, it's kludge time. So you go into SolidWorks, and since this is an assembly, it's nice. This sketch, the 2 sketches I made, they live inside the assembly, which is where you want them. Because the whole point of an assembly with fixtures is you're not going to add stuff to the part file. You want to keep that kind of uncluttered with any CAM stuff. Just keep it straight part file. When I start making parts, I'm going to have assemblies with just one part in it, because that way the assembly gets all the CAM stuff, all the HSMWorks stuff goes into that file, and the actual part file isn't touched. So here we are, 2 sketches. The north-south kludge, you can see it turned blue. So ignore this gray. So here's the blue, right, going around the north-south clamps. And then the east-west kludge, that's, the boxes that it weren't done. And that's what we're going to use as geometry. And you say, oh, okay, that's great. So now we can do, here's the problem. There's going to be pads under these north-south ones. So you say, okay, here's the face, and because here's the toolpath, right? You can see it. Okay, it's going to finish that off. Let's simulate that. Well, it won't show you the stock condition. This is a generic problem with this program and a very serious problem. It doesn't show you I haven't figured out a way, maybe I just operator error, to show me, no, I want to see the stock the way it was left from the north-south facing. So this causes a problem, right? Let's do stock simulation. And we're pretty slow here. We'll go here. And you notice it's bombing through these clamps, but that's not a problem yet. Okay, oh darn, so it doesn't show that right. But here is where it complains. I learned about the right click, where you can not only flash on clash, which doesn't work for me, there's also export. where is it? There's save the stock. So that's their design intent. I think if you got 50 operations and then you want the next one to show you the stock the way it actually is, export it as an STL, bring it into a program that convert that into a solid part, then use that solid part as your stock for the next, what they call job, which really should be setup. There's this thing fixture here where you can turn fixtures on and off. We'll show you that next. But okay, so it did it. Didn't do it, but it's not showing it correctly because they don't honor stock condition. Let's light up both of them. Or you could light up both operations. Say stock simulation. Go do your thing. Speed it up a little. See, and now it's bombing through and it's bombing through. And now it shows cleaning up those areas. So you're kind of confident, okay, it didn't leave any little islands. It actually did what it's supposed to do. It overlapped where it had to overlap. So what next? I want to show here, notice that all the clamps have lit up. Let's close it. But in this setup, when we edit, the only clamps selected in this setup are, I must have something, short clamp. Okay, you saw it turn blue there. So, the darker blue, duh. These are the clamps selected for that setup. Cancel out of this one, edit. For some reason, when I picked this bolt, it also highlighted the entire part model. It doesn't seem to affect things, but that's a bug. Okay, nobody's perfect. But see, there's no way to do a simulation now that will reflect the true stock condition, how this part's being machined, and not generate collisions. Watch. So we'll do, oops, you can't do it that way. You got to do this way, right click. Stock simulation. Then, this is another irritable, the only way to check against those fixtures you define in each setup, or job as they miscall them, go there. But see, they've all lit up. So if you go to machine it, as soon as it bombs through these, you'll, bam, there they are, clash, clash, clash. Oh, darn. So there's more clashes because these are defined. Okay, so you figure, hey, let's, I actually prefer to restart it from scratch just so you know where you're at. Okay, so we learned about this right-click business where I did set it to flash and I ain't seen it turn red like everybody's videos. Fixture. Oh, see, we didn't, God, this is so clumsy. Here. Wait, let's go up higher so I can read it. Fixture. Turn that clamp off. And like always, they dismiss the dialogue even though there's 42 things to click. This is just normal programmer. Don't use the program, just write it. Okay, so we're going to turn these off. And I only can remember, I should have named them better, I guess. Okay, so now those fixtures are off. So my thinking is, all right, we're going to do both, but we'll turn these off, do the first part, pause it, go change around to the others, and then finish it, and we won't get a crash. Wrong. As soon as it hits these, even though they're not highlighted, boom, there's all the crashes. So that's why I say botched. It might be something they intend to fix. But, and I didn't go through with obviously halfway through, switch it to the other ones. Why bother? It's crashing here. So there is no way, what I found, the way to work it, do each one individually, right? Even though when you do this, you don't really see the stock condition the way it should be, right? But you can check for collisions. Now it's checking the right pair because it's only simulating one operation inside that one setup where we've defined these clamps. Sorry, this is so goofy and programmer-like, but so now, right, didn't hit anything and you get the happy ending. I don't get red tools, but I get the happy ending, right? Okay, it didn't generate all kinds of clashes here. And this box I've got half pulled over, right? I move it around. I got multiple monitors. So you do that with that, and then then you just don't highlight the thing. And if you want, you can go over. It won't work with. You got to get out of the simulation. Then you can go over here and say, "Don't show me the clamps." Go back here. Do both. Say stock simulation. and do its thing. And because you've ensured there's no collisions in each individual one, now you can evaluate, is it really removing the stock the way I want? This is bad, right? I mean, it's not the end of the world. It's kludgy. You got to do sketches. You know, they really need to get this fixed, but they need to fix it in a broader, systemic, fancy word, way. Okay, so next, get out of the simulator. We're going to file save this, although I haven't changed anything substantial. This was part fixture undercut 2D solid assembly. These will go up on, I'll pack and save them, and the original, version, no toolpaths, that'll be up there. This one, and now let's switch to the 3D one. And like I say, I wish I could do this real time for you, but when I tried today, I couldn't remember the 62,000 things you got to set. Now, in order for the simulator to understand it's hitting things, right? That's orthogonal, as my scientist buddy would say, from the avoidance being done by the ModuleWorks 3D toolpath module. It's built inside, probably built inside HSMWorks. Most companies. I think only SolidCam did their own eye machining. They probably did their own. But where were we? Edit. And you can see, same deal. It's selected, I actually didn't select the wedges, but no big deal. Okay? So cancel. So you need to do that to see what the simulator is doing. Then 3D adaptive toolpath. I'm just going to tediously go through this because I truly can't remember how I got here. The trick, the most deceiving, non-intuitive, goofy thing on the history, it doesn't obey anything, it doesn't avoid anything until in geometry, where you would least expect it under model. And you can see, I think I actually bolt countersink. To get it to work, and I'm not sure, this might just be a mistake on top of a mistake, I had to select the model itself and then all of the clamps. Now it'll avoid, right? And height, it avoided the tool. It will not avoid the holder. So that's one problem. So then I went to a longer tool, so the collet and the tool holder was above all these bolt tops. And I know this is a goofy setup, right? This was purposefully designed to trip up CAM programs. The tall bolts, all of that. It's not really the way I'd make the part. Don't get on me for that. Then the other problem, it will bomb toolpath when it does, like, it crosses over through this clamp. So I had to raise, I think, is it this one? Yeah, the yellow one. I had to raise this up above this surface so that when it does happen, bomb through the clamps, it doesn't cause a problem there. So close out of it. Let's do stock simulation. And we can turn on here because, see, we haven't lit up both operations. We haven't lit up both setups in when we asked to simulate. We're only simulating the first operation. So when you turn this on, it turns this on. And this is how to bless their heart, when the holder hits this bolt, it will tell you. Okay, so you go here, and I still haven't figured out how not to do the corners. When I say just go from top stock to bottom, top of stock to top of part, it doesn't, it reds out and refuses. But when the little happy ending thing comes up in a second here. Okay, so since there's no clashes listed here, my tool never turns red, sorry. Oh, here's the other kludgy thing. The only way to avoid, if you have to go, edit the toolpath. In here, I think, is this not load, cutting radius, step downs. Somewhere you've got to tell this thing not to get too close, which is why it's not accurately doing the corners. See what I mean about so complicated? I would think it would be this one, optimal load. No. And why is that in inches? Oh, heavens. It's not a radius. Stock to leave, 1/10 of an inch. So click stock to leave, which means That's why I want to separate this and maybe in another 3 days figure out, no, just do the top, right? Don't do the sides because you're leaving stock here on the sides because this is the only way. When that's 0, it brings the tool mathematically up to so close that the collision, a completely different program, collision detection says, oh, you've got all these collisions because the tool just mathematically touched the clamp. So that's kludgy, right? But you can go through it. You can, change your planes. You can make sure that there's no yellow line. Lots of work. Yellow line going through. Okay? Then do this one. Same deal. No stock condition. Not the way that I figured out. Oh, let me show you that. Edit. Oh, I didn't go through them one at a time. I'll get back to this. Okay, tool, a big long tool, goofy tool. Here is where you can say rest machining from previous operations. And even though it crosses a setup or a job in their jargon, it seems to obey. And, it didn't try to machine the whole top. It just truly machines under where those clamps were. So that was a trick. We'll go over this at the end. So, tab by tab so you can see what the heck I did. So here, stock simulation. Once again, it shows you the stock that you have to make as part of the setup because they don't let you just inherit stock from the previous setup. Major, major shortcoming. Oops, doesn't like it. It's clashing. I guess maybe I should have checked this better. Slow it way down. Start over. Passive aggressive. Did you really want to start over? It's saying it's clashing with the stock for rapid movement. Okay, so like I said, unlike the demo programs, come on. What are we doing? We are edit. I'm learning my way around here a little better. Good gosh. I've pulled the clearances and the retracts an inch up. I can't do anything else to get this further away. From model top. Let's try from stock top. 0. Say OK. Not edit a protected. Do you want to unprotect? Yes. So is it unprotect? I tried this unprotect thing like when I made that chamfer and it cost an hour's work. It doesn't protect when you change the model and you put a chamfer. We'll talk about that later. Suppress, where was it? Protect. There's a protect. Okay, so it unprotected it. You need more user interface fun, a magnifying glass because the icons are so minuscule on a 1920 by 1200 monitor that you have to kind of look at them. I think there's a red X there. They also use a red check mark when it's okay, right? Now that's an achievement. How about the color green when things are okay? That's, I think in Denmark they do that. Generate toolpath. No, it's still got a red check mark. None. See, this is when it's not happy. So you get to see me mess with this 5,000 times. This is why I had it preset up and didn't think I have to touch it. From model top, see because the model selects these, it's up here. This is just kludge, right? This is just botched. So, well, wait a minute. This is where I had it before. Generating. Okay, so now it's happy. Let's try to stock simulation. Let's turn on the things and let's do our thing and see if it crashes. No, it's still clashing with the stock. So another computer science degree, 4 more years, get the API for the HSMWorks module, and maybe, you can see I'm getting a little upset. Maybe I'll figure out why these clashes. But I've learned one thing in my life. If this thing complains, under no circumstances ignore that and think, well, I understand what's happening. Because nothing programmers love more is putting it to you, luring you into thinking it's going to be okay. But of course, it's not showing the stock condition. Same problem, right? Although it does a cleaner job of just fixing the things it has to fix. Notice it didn't clash over here. I guess maybe because it thinks the stock is at the top of the model. I don't know. I'm just disgusted. So, okay, so here's the deal. Okay, let's do this one. Hold the control key down. Let's stock simulate. You get this same problem. If you turn them on, you get them all. And, well, I haven't tried it on this one. Let's try. Oh, I can't see it. Good gosh. Could you make it more tedious to do this? Okay. So now let's do here. And let's speed it up a little bit. It's doing its thing. It's doing its thing. See, as soon as it hit the clamp, boom, 1,000 of them showed up. So that's dead action, as they say in the pool room. There is no way to simulate this thing that will both show the stock condition for that second operation as well as tell you if it's clashing or not. And of course, I can't even get it to work once. So I'm annoyed. We're going to end this show a little early. See what I mean? Botched. You want to see it right? SolidCam. And we'll talk about what SolidCam did that's so wonderful. Let's do File, Save. I'll pack and go this one. And as you might remember, this is Fixture Undercut 3D. Okay. What to do to fix this mess? It goes back to systemic, basic problems that the Danish programmers had when they invented this program. They do not distinguish between a job, which is where you make a whole part, and a setup, whereas you flip that one part around 52 times if you have to in a vise to do all the operations needed to do it. Because they've put those together, it just ripples through this whole program. The other aspect is they don't honor configurations. So if the setup would let you select a configuration, the way I'm not sure if SolidCam does it there, but it certainly does it in the operations. And you might want them in both, right? So that there's like a parent in the fixture, right? There needs to be job. In the job, you decide what machine it is. You tell it the stock, right? That'd be a good place. Okay, here's all the stock stuff. You only do the once. The way it is now, you've got to redefine the stock over and over again, and you tell it, oh, do it from the last, and I can't even see what that does, right? It doesn't seem to affect anything. So then with this new concept called fixture, right? Or I'm sorry, not fixture, setup. A new concept. So under a job, there can be only one job per file. That's fine. Then you can have multiple setups. In those setups, there's only a couple of things. One, part 0. Not stock definitions, not anything else. Just what corner this thing is on and what direction it points. Part 0 and orientation. Origin, orientation, done, the way Visual Mill does it. Next, you need to tell it every setup where its fixtures are, where the clamps and the vices and all of that business. And you don't need to do it separately in the 3D operations. They got to fix that. But then the big job, once they fix those systemic problems, then maybe they can go into their 2D toolpaths and start doing fixture avoidance. Inheriting from the setup what fixtures, inheriting each operation, like SolidCam, you should be able to say, this is the SolidWorks configuration. So then, even more work, and I know this is a big ask and it'll never happen. You know, I actually considered dropping $5,000 on SolidCam after this frustration the last 2 days. After you do all that work, programmers, then you have to make the simulator honor things. The simulator has to honor those configurations so that as it simulates, the clamps start moving around and the avoidance is avoiding and the collisions show up as collisions. So that has to be fixed. So one of the things that made me not go back to SolidCam, when I did some 3D toolpaths or iMachining they're so proud of, the file grew to 8 megabytes. I'm sorry. That's bloatware. I can't deal with that. So real quick now, 24 minutes. Let's go look at how I magically got this thing, all the goofy things I had to set. It's a new operation, 3D milling, adaptive clearing, I think, is what I picked. And this is the problem that oh God, what's his name? There's a fellow who's doing a bunch of 3D toolpaths and stuff. Fantastic, right? He does YouTube videos on it. Let's see. I'll put it. I'll write it underneath. Okay, so what are we trying to do? We're going to edit this to show you the 52,000 things I had to mess with. It'll avoid the tool, the 3D toolpaths. It'll avoid the fixtures, and the tool will avoid the fixtures. The holder won't. So the holder was clashing into the bolts. So to fix that, I had to go in the library, pick this ridiculously long tool. And yeah, I know this isn't practical, but please, we're just trying to show shortcomings. Here, I didn't put a boundary. Maybe that's my trick. Put a boundary in here of the edges of this, and it'll stop doing those corners. Because that's the thing with 3D, like that fellow explained. In 3D, it's trying to machine everything, right? Because the HSMWorks module is, let me at this thing. It's stock aware and it's model aware. So it's raring to go and just carve everything it can carve with that tool. So most of your work with 3D is, no, don't go crazy. I just want this little bit done. Somehow miraculously, I got that. I only selected the face. So maybe that's why it's not doing the pocket. Even though this is the first operation, I think it needed rest machining here from job stock, which is, yeah, that's where we started. This I didn't touch. And then here's the trick, incredibly obscure and non-intuitive. You got to click on model and then select. And I'm pretty sure if I didn't select the thing itself, it blows up and does 15 levels down. It doesn't, except that it's trying to machine that. It's trying to machine the bolts or something. Here, heights, I had to mess with these just because, let me think. Well, no. Here, the tool was smart enough. Now, this would be another place maybe I could have messed with it so the holder wouldn't clank into the bolts, right? Instead of that ridiculously long tool. But I don't think so, right? Because, well, goofy, right? Here, I don't think I touched anything both ways. I might have checked machine shallow areas to get it to flat happen. Ask for climb milling, always climb mill. Here's where, so it wouldn't just touch the clamps. Okay, give me 1/10 of an inch around those clamps. I guess you could use 1/2 inch and really make sure you could be sloppy when you put your clamps in, right? And then I never mess with these linking stuff, which is a credit to the program. So that's that. This one here, edit. Same thing, the tool, the same goofy tool. Same phase. Matter of fact, I did a cut and paste and just copied it over. And then the only thing I changed is I erased all of these that was in the first one that I copied and pasted and reselected the other ones. Right? So this is where you define what it's trying to avoid. Heights, I think I had to mess with this a little. Model top, model bottom. I don't know. Because you lie to it about what's the model. Like I say, the module works. It's kind of like the HSMWorks program said, well, we can trick ModuleWorks into doing avoidance by using the model tab. Not good. Oh, wait a minute. Back to geometry. This is critical. Rest machining, but not from job, but from previous operations. Like I say, I had to click so many things in such an arbitrary fashion, I can't even remember. Stock to leave. This wasn't important. I guess I could uncheck this because when you finally teach it, no, I want a rest machine, just those little pillars that were up, it doesn't get close to the old ones. And then linking, I didn't mess with that, right? And I'm sure there's plenty of operator errors. Get it up high, long tool. So, like I say, I was so disappointed. Go look at the SolidCam one, just how clean it is, how it handles the different configurations, how the simulator honors stock condition at any point in time. All that has to happen. This is why I've taken HSMWorks from the, capable Mastercam quality and moved it into the hobby. So HSMWorks, Visual Mill, Bobcat, hobby programs. Mastercam, SolidCam, pro programs. My problem is, for an intermittent user, SolidCam is not intuitive. They got these huge dialog boxes. You're getting carpal tunnel swinging around. They don't label anything, so you don't, if you don't use it every day, okay, now is that import the tool or is that import the whole thing? So, and that the other aspect with SolidCam is these huge 3D iMachining files that it generates. Sorry, I just don't need that big of, even though my Mach 4 mill would probably take a huge file, it's still not going to happen. So I'm going to live with this, probably never using the 3D with fixtures. I am going to live with it by doing that kludge with the 2D, like I showed you, using sketches and just manually avoiding fixtures and using their kind of kludgy collision, which, bless their heart, will tell you if it hits the holder as well, and go back and forth doing that. And there's no way to do a complete simulation across multiple job setups, but it's better than nothing. You can do them one at a time, then just poof the clamps, disappear them, excuse me, in your SolidWorks configuration, and then watch it work and live with that. So, botched, but nobody's perfect, all right? Sportster Paul, good luck with your CAM project. We'll catch you next time. Bye now.